Okay, gang, I just wanted to do one more point on this graph. My DS card had passed out on me. Okay, so let's do the point 2, 0. So first of all, on the graph, let's find it. So 2, 0 is right here. Whoop, oh, I guess that one's not going to work. Okay. 2 zeros right there. That's, oh, let me not write the point. That's the point 2, 0. We want to find the tangent line to that point, right? So what we're doing with the calculus is we're finding the derivative, the slope at that point. So again, the formula is f prime equals 2x. So I'm going to put in a 2. So 2 times 2x, where x is 2, is 4. So it means that the slope here is 4. And again, if you want me to find the whole equation for you, the y equals mx plus b, right? We know that y is 0. Y is 0, m we just solved is 4, x is 2, solve for b. So this is a slope, but the equation of the line, if we wrote it, which should make sense, right? Because it's going to come down here and cross the y-axis pretty low down. So just some basic observations. You can see that this one has a negative slope of -2 because it's coming down. This has a slope of 0 because it's flatlining. And this has a slope of 4 because it's upward. It's going upward. Alright, gang, so I hope that so far is clear. So just to quickly reiterate, you're finding the derivative by the limit process. That is giving you the instantaneous rate of change. And then that gives you a general equation that once you know which spot you are on the graph, you can then find that specific slope. So the derivative in general is a slope generating equation that you can then use later on, because the tangent line will change everywhere on this graph. It's not a static concept. The only kind of thing where the slope is fixed is something like a straight line where the slope doesn't change anywhere on the line. Alright, let's just do another example. I just want to make sure. So that's the lecture. Well, there's a little bit more I'll add in a moment, but overall that's the really most important piece. So let's try another example. So we're going to find the derivative by the limit process. So you also have to recognize this wordage when I use it on the test 1 and the final exam. Limit process is this long thing that we're doing now. Alright, so like I said earlier, you take the initial equation, everywhere there's an x, you put an x plus h, right? So here's an x, it becomes an x plus h. Here's an x, it becomes an x plus h, right? So everywhere there's an x, it's got to become an x plus h. So this is the f of x plus h. Minus the original, right? This is the original, all over h. Alright, now if you notice, this is now going to overlap with what I was teaching you from chapter 2. Because if I take the limit as h goes to 0, this is indeterminate. It's 0 over 0. So now you have to use all those techniques that we discussed, right? So if it's a radical, you're going to rationalize. But you're going to multiply by the conjugate of this. Right, we're going to multiply by the conjugate. I'll write out all the steps. Try not to lose this, because you shouldn't lose it. First of all, it's an operator. But also, if you lose it, then your final answer is not going to make any sense. Alright, so this times this this times this. I'll write, you don't have to write them. You know the middle steps are going to cancel, so you don't have to really write this part, the middle steps. I'll write it because some people might get confused if I don't. I'm not going to FOIL it out though. They're both under the radical. All right, this times this. And then this times this. So this is where you're going to see students will screw this up because it's a little confusing. A positive times a negative is negative, and then this times this is x plus 4. Now if you notice, I'm putting it in parentheses because I have to make sure that I subtract both of those because it's minus that product, and that product is x plus 4, so it's got to be minus both of those. All right, if you combine like terms, this goes away. And let me just add an extra step here. So I'm going to distribute this negative. It's minus x minus 4. Oh, I forgot to add the bottom here. Let me not lose that. That's important. And again, the side that you're moving it to, don't distribute it out. So I'm not going to FOIL. I'm not going to distribute the h in on the bottom here. And if you forgot why you don't do that, I'll show you in a second. Alright, so I'm going to keep combining terms. So technically what I'm saying is if you'll write to here on the test, it's fine because the middle terms will always cancel for the conjugate. So you don't need to like write this and this. You can go right from here to here. Alright, so now let's combine like terms again. This and this go. This and this go. And again, the reason why you don't want to distribute the h is that it's going to screw you up on this step. You won't be able to reduce this. All right, now you're going to take the limit, so you're going to let the h go to 0 in this. Just make sure, oh, hold on, that's not an H, that's a 4. Just always give me a little bit of grace time if I write something. Hopefully I catch myself, but making the movie and thinking and write, it's an interesting process. I think I got it down, but every now and then my hand might not do what my brain wants it to do. Alright, so this should have been a 4, we fixed that. We're taking the limit now. So now you're going to have 2 of these, right? They're identical, so it's like an orange plus an orange is going to give you 2 oranges. Alright, so this is the derivative here. This is the derivative. Now remember, this is your slope generating function. So now let me add an extra step here because I would do this on the test. So you have the original function. You have the slope generating function. And now I'm going to ask you to find the tangent line to f at, let me pick something that's not too crazy. Let's do it at, okay, let's do it at 5, 3. Because if I plug 5 into here, that makes 9. Square root of 9 is 3. Alright, so let's do it at that point. So you're going to now do the y equals mx plus b. We know y is 3, and we have to calculate, right? You have to calculate the slope from here. So I'm going to need my x value to do that. Oh, I'm trying to find the tangent line at this point. So I just need to put the x in here. So 5 plus 4, that's 2 over the square root of 9, or it's 1 over 2 times... Alright, I guess that actually works. I should just go with it. 1 over 2 times 3, which is going to be 1/6. Okay, so the slope here is 1/6. when I shift the page back, I'll lose it, so I'll write it underneath. Alright, so the slope is 1/6. The x value is a 5. We're going to solve for b. So 3 equals 5/6 plus b. So we're going to move the 5/6 to the other side. Right, you're going to subtract this from both. You're going to subtract this over here. Alright, so 18 over 6 minus 5 over 6 is b, or 13 over 6 is b. You could just leave it as a mixed number. You don't have to convert it. Sorry, you can leave it as an improper fraction. You don't have to convert it to a mixed number. Alright, so let's just go over the basic details here. This is the derivative, which gives you the slope at every point on the graph. Now, if you want to see the graph, I'll draw that for you. So your original function is this. So that's a graph shifted 4 units to the left, because it's a plus 4, so it's over here. It has a y-intercept of 2, so it looks like this. So what we did was at the point 5, at the point 5,3, which is approximately right there, we found the slope. We found that the slope was 1/6, and we found that the tangent line at that point was 1/6 x plus 13 over 6. Okay? So we have the derivative, we have the function. This is what the function looks like. I asked you to find the tangent line at the point 5,3. So for you to do that, you had to plug the 5 in to find the slope, and then you had to then find the equation of the line. So to do that, you had to plug in the y, m, and x to solve for b, and then once you did that, you were done. Okay? So a question like this is the kind that I love to give on the test, where you find the derivative, you first find the derivative, then you find the slope, and then you find the equation of the tangent line. Right? Because this is just the slope. This is all the way to the equation of the tangent line. Okay, I'm going to end this video here. I just actually have a little wrap-up concepts I'll get in the next one, because this is already this is over 12 minutes. Alright, catch you, gang. Bye.